Alright guys, here's a little help for 19 DCP we did in class today. I'll just kind of review what we did in class. The first step was to construct a right triangle. So you leave some room above it and you draw a line, and then you're going to use your protractor. Okay, so let me find my protractor. You're going to put your protractor at the end and find out where 90 degrees is. Make a dot up here where 90 degrees is. Okay, oops. And then we're going to connect this last line with that dot. And you really want to double check and make sure you get a 90-degree angle, because this doesn't work if your angles are not exactly 90 degrees. So you should then put your protractor back on top and verify that you've got exactly 90 degrees. So you can see mine's exactly 90. Once you get exactly 90, you can put your little right angle symbol in there. That tells us that it's a right angle. And then you can also connect. You connect your last two sides. You can make them any size you want. I wouldn't tell you to make them the same size because that might be a little difficult later, but you can make these any size you want right now. And you're going to label them. Letter C is your right angle. That's what step 1 tells us. Here I put A, and then here I put C or B. That was step 1. Step 2 was to construct the altitude. That's where you actually need your compass. So you get your compass setting. You put your compass on C, and you open it up so it's a little bit past the hypotenuse. That way, when you do your smiley face, because that's what you do to make a perpendicular, it'll touch your hypotenuse in 2 places. From those 2 places, you put your compass on there. You put it right on the spot where they touch. You can make it a little smaller now if you need to. And you're going to make an X above these, where these 2 intersect. Okay, so somewhere right around there, and then you make your X. Then you connect point C with your X. You need to get it right through the middle of the X and right exactly on point C. If you do that, then it should be an exact perpendicular. To check it, you bring over your protractor. You spin it so that it's the same as the hypotenuse. Something similar to that. You can see 90 degrees, and it's there. So that's exactly a 90-degree angle. So once I've double checked that, I can actually put in my little right angle symbol. Get the right angle symbol, spin it around so that it fits right in there nicely. That point you're going to label as point D. And once you've used your smiley face to make that X, you can get rid of your smile if you want, because that way point D will fit in there a little bit better. And that was 2. Number 3 says you're going to measure your angles. So you're going to measure all the acute angles. So you're going to measure angle B. And if you look on mine, my angle B, I'm going to use the outside numbers because that's my 0, 10, 20, 30, 4 degrees. So I've got a 34-degree angle down here. And then to get the next angle, I'm going to turn my protractor sideways to measure, oops, wrong way, this direction. Okay, so that way I can put it on angle A, exactly on A. It's on angle A, and it's not quite, it's close, a little bit up, there we go. right through 0, and 0's on the inside this time. So that looks to me like a 66, no, 56 right there. 50 and then 6. 56 degrees. And I actually know that I did mine correct, and I measured it right, because 56 plus 34 are going to add up to 90, and then plus angle C is 90, so that gives me my 180 degrees for a triangle. They also want you to measure these two acute angles. So I'm going to leave it on this protractor the way I have it, and I'm just going to put it down here on angle C. And I'm going to see, I'm going to use my outside numbers, 10, 20, 30. It's a little high right now. 30, 34, 35. Actually, it's 34. I'm going to make it bigger. You can see it's on 34 degrees. It's close to 35, but a little less. So I'm going to go with 34, which is what I need, because it should be the same as this angle B down here. So 34 degrees. And then that tells me that since these are a right angle, these two together are complementary, this one has to be 56 degrees. Although I am going to measure it just to double check. But it should be 56. So let's bring my protractor to 0. Let's put it on angle C here. And we can see perfect 55, and one more is 56. So exactly 56 degrees, and I'm right on angle C right there. So that would be number 3 done. Number 4 is the last one we actually did in class. And we sketched 3 triangles separately. Now this is not something you needed your protractor for. I just said you can make 3 representations of your triangle. So all you're really doing is drawing 3 triangles that kind of look similar to the triangle that you made here. You just have to look similar. So what I'm going to do is I'm going to make it similar here. I'm going to make it a right triangle. To make a right triangle, kind of looks like that, kind of the same shape. Short here, longer on the bottom, longer on the bottom. I'm going to put a little right angle box in there. Actually, let me duplicate this first, because we need 3 of them. We need a small, we need one that's a little bigger, so it's still the same kind of shape, but a little bit bigger. And then we need a large one too. So I'll have one more over here, and we'll just make it a little bigger for my large triangle. What they want to see is, can you match up the angles in the right place? So that's what they were trying to check out here. Let me put the right angles in all of them. Alright, so if this first triangle right here represents this little triangle right here, that means that this bigger angle up here, the bigger angles across from the bigger side, the bigger angle is 56 degrees. So this just represents my 56 degree angle. It's not exactly 56. I didn't measure it, I just made a representation. I'm just saying that this angle represents my 56 degree angle. This angle down here represents my 34 degree angle. Oops. So now I've got where my 56 would be, where my 34 would be. And that's going to be the same in all these triangles. These other two are also going to be your 34 degree angles. It's just what they represent. And then the 56 degree angle would be this, representing this top angle, because they're not exactly 56. I didn't measure it. And let's see, so my 56 degree angle in my little triangle right here, the little triangle, the 56 degree angle is A. So this is where A would go right here. In my little triangle, my 34 degree angle in my little triangle, the 34 is down here at C. So this is going to be letter C. And then my right angle in my little triangle, my right angle, I could have put a box right here too, would be letter D. My right angle is D. Oops. So there are my letters for the little triangle. That's what they would be. The medium triangle is this one. Letter B is my 34-degree angle. So that's the letter B right here. In this triangle, my letter C is my 56-degree in this triangle. So C is up here. And then, of course, in this triangle, D again is my 90. So there's two triangles that have D as 90 degrees because there's two 90s on this letter D. And the last one, C, is our 90, which we already drew. And then A and B were your other two. A is up here. And then B is down here. Now what the step 5 is asking you to do, it's asking you to measure the lengths of the sides of your triangle here. Okay, so if I was to say measure this piece right here, I'm just going to put some numbers in. They're not right. They're just numbers that I'm just so I can show you an amount. Let's say I put this in, it was 2.3 centimeters. That means I'd also put 2.3 here because that's where that would represent that side of the triangle. My short side of my little triangle would be right here. Let's say I measured this long piece right here, and it was like 5.2. I'm just making up some numbers. You're actually going to measure these. You're going to measure these sides and get real numbers. That would be the hypotenuse from A to C on my little triangle. A to C would be right there. That would be 5.2 centimeters. And then from D to C right here, let's say I measured that and it came out to be, I don't know, like 4.8, say. I'm just making up numbers. All I know is that the hypotenuse, AC's got to be the biggest out of these three numbers. So 4.8 would be a smaller number there than 5.2. That would be my little triangle. Those would be three measurements. Let's say I measured this longer piece here, and it came out to be like 11.7 centimeters. Just, again, making up numbers. And then I measured this long piece right here, and it came out to be like 14.8 centimeters. Now we could fill in my medium triangle. Medium, the small side, is 4.8. Now my numbers are not going to come out right. I'm just telling you that right now. I'm just telling you what they want you to do here. 4.8, and then the bottom side is this 11.7 dB. dB down here at the bottom. D to B, so D to B would be my 11.7. And then from B to C, B all the way to C, B to C is 14.8. So that would be this one. Then from A to C we already measured 5.2. From B to C we already measured 14.8. And that's not going to come out right. No. Let's make this one 13.8, guys. Sorry. I just want it to be out. I just want it to be make sense. So let's change that one to 13.8. Because now this piece right here are these two pieces added together gives you AB. So it's 2.3 plus 11.7. And that's going to equal 14 even. And it's the biggest side of the triangle. That's why I had to make the other one a 13.8, because this one has to be the biggest side, just so it'll make sense. So now you have the three sides of your triangle. Now you're going to show me that they're similar. You're going to put 2.3 over 4.8. And show me that it's going to be equal if you put 4.8 over 11.7. And that's going to equal 5.2 over 13.8. Those would all come out the same ratios. These would all be equal to each other, and you would reduce them and you would show me that they're all equal. Now everybody's numbers in the class are going to be different because not everybody made the same triangles. So what you would do is you'd make your fractions. I did 2.3 over 4.8, I did 4.8 over 11.7, I did 5.2 over 13.8. Then you could do 4.8 over 5.2, 13.8 over 14, and 11.7 over 14.8. And you could show that they all come out to be the same ratio. They all come out congruent there. If you reduce these, they should come out congruent. Now, mine aren't, because mine are just made up numbers. I didn't measure these. I just made them up just so you can see what to do on yours. You're going to measure, you're going to make your fractions. All the fractions should reduce to the same fraction. And then this number 6, you're just going to summarize what we learned about similar triangles, about what happens when you put an altitude to the hypotenuse in a right angle. What does it make? What do we know about these three triangles right here and all that stuff? So that's what goes down in this area. Alright, see you guys later.